Welcome to Brain Vision.
So there's an object that's falling from a height and stretching a spring, and we can write out the conservation of energy for this right away. So we have change in kinetic and change in potential. We have to split into two parts. We have the gravitational potential and the potential energy from the spring. So kinetic energy, gravitational potential energy, and spring potential energy, they're all going to sum to 0 because we have no external work to worry about. Now the object is starting and ending at rest, so we can forget about kinetic energy because it's not moving at all. So this is just going to be mg times delta h plus 1/2 k, and then I'll say x final squared minus 1/2 k times x initial squared. Now the change in potential is going to be mg, and the change in height is negative because we're falling down, and the total distance it travels is going to be the 1.2 meters plus however much the spring stretches, which is x final. So this is going to be minus x final plus 1.2 meters. Now x initial is 0 because it's not stretched at all, so this term we don't have to worry about, and we just get plus 1/2 k x final squared. And now we have basically a quadratic, so I'll try to make it look more like a quadratic. So I'll bring this over, and we have 1/2 k times x final squared. Now I'll expand this term, so we have minus mg times x final, and then minus 1.2 mg. So this is a quadratic with a, b, and c. So I can plug in to the formula to get x final, which is what we're looking for, how much the spring stretches. So that's going to be mg plus or minus the square root of minus mg squared minus 4 times 1/2 times 320 is the spring constant, and then minus 1.2 mg. I guess I didn't need to, I'm not plugging in numbers just yet. And then divide by, well, it's going to be 2 times 1/2 times k, so this is just k, because we need 2a on the bottom. So now I can plug in the numbers. This is going to be, the mass is 1.5 kilograms times 9.8 plus or minus square root of, well, the minus is going to go away, so I don't need to worry about that for now. So this is 1.5 times 9.8 squared minus 4 times 1/2 is 2, and now I can plug in the 320 for k, and minus 1.2 times 1.5 times 9.8, and then divide all of that by 320, and we get x final is 0.381 meters, so that's how far the spring stretches. Now if we also had air resistance, it's only going to change one little thing. We don't have to do much. Instead of having a 0 on the right side of the equation, now this becomes basically work due to the air resistance. So I can write that. I'm just going to rewrite everything over here, get rid of the zeros. So this is, I'll just call it little f for the force times however far it's going to act upon, which is x final plus 1.2. That's the total distance the object travels. And then it has to be negative because the work is resisting, so it's pointing up, and the object is going down, so they're in opposite directions. So this final equation is going to be equals minus f times x final minus 1.2 f. So we can actually bring this here and this over here and combine some of these terms. So we end up getting 1/2 k x final squared, and then plus x final I can factor out times f minus mg, and then plus 1.2 times f minus mg equals 0. So the only change I'm adding in here is just adding the f's into the last two terms. So I can basically, I'll just copy this whole equation. And we can add in, let's see, what do I want to do? I want to say f minus mg, but actually this is negative b. So this is mg minus f. And then in here, add in an f. And in here, 1.2 times f minus mg. Okay, so now let's plug in these numbers. 1.5 times 9.8 minus 0.7 is the force. Plus or minus, and we're just using the plus actually, which is because the last answer, if you did the minus, you get a negative. So we just want positive answers. This is going to be 0.7 minus 1.5 times 9.8 squared minus 2 times 320. I'm actually move this over a bit. Times 1.2 times 0.7 minus 1.5 times 9.8. Okay, and then divide all of that by 320, and it only changes the answer by a little bit. Now we get 0.371 meters. And now for the last part, it's basically the same as the first part except we're changing g. So I'll just paste what I had before. This is the part we had for the initial. I'll get rid of the minus. And we're just changing g. So I'll actually copy this expression here. And all we have to do is change 9.8 to 1.63. And here. And, oops. This one. And now evaluate this, and we get 0.143 meters.